can we utilize the ideas of division of regular numbers into divisions with expressions that have x squares, x cubes, and x to the fourth, so on and so forth. My contention is this. If we pass the 5th grade, which I'm assuming we all have, you guys already have the skill sets down. The same knowledge, the same stuff that your 4th grade, 5th grade teacher taught you will be the same stuff I will teach you, which I guess I'm not teaching, I'm just reminding you. Because the same division algorithm that we've learned way, way, way back when is going to be the same concept and idea that we're going to apply today. So let's not do pre-calculus right now. Let's go back to happier times, 4th grade, 5th grade. Right. Let's go back to just good old-fashioned division. Suppose I ask you to divide, and I'm just totally making this up. Throw out some numbers. 7, 3, 4, 1. I'm just making it up. Let's divide that by 4. Right. Now, I'm going to make an assumption here. I'm going to assume that in the 4th and 5th grade, you were in a school in the United States, because in the United States, they teach us this particular division algorithm. If that is not a true sentence for you, well, speak to me after class and I'll show you the division algorithm. But for the most of us, if you were presented with this question here, you would draw this little bracket. You would put the 4 on the outside because that's what you're dividing by, and you put the 7341 on the inside, and then you would do your normal progression. So the first thing you would ask is, okay, how many times does 4 go into 7? Note, we said 4 into 7. We didn't say how many times does 4 go into 7,341. So you only look at the first number when you do the division algorithm. So of course, we know the answer is 1. So that was the very first thing that we did. We divided. Then our 4th grade, 5th grade teacher told us, okay, take your quotient, that number 1 there, and you multiply it by your divisor. And whatever answer you put it inside the division the division bracket. So your second step is to multiply. And then your elementary school teacher said, all right, go ahead. Once you have your answer, subtract what you have. So we do 7 minus 4 gives us 3. And that was the third step that your elementary school teacher told you. We're going to subtract. And then last but not least, your elementary school teacher probably told you, you know what? You're going to bring down the very next number. And that 4 steps, that 4 process is one complete cycle of what is known as the division algorithm. And then your elementary school teacher probably told you, just be an engine, the little engine that could. Just keep chugging away until you finish. And that's dividing, right? That's good old-fashioned, I don't have a calculator with me, long division. So let's just quickly finish this, wrap this up for the completeness of the note's sake. 4 goes into 33 8 times. 8 times 4 is 32. You subtract 1, bring down the 4. That goes into 3 times, 12. 2, bring down the 1. 5, 20. With the remainder of 1, all right? So the answer isn't what the important thing is. I wanted to get to the remainder. Now, in 6th grade, 7th grade, you guys probably learn, place values, and your teacher probably said, hey, add a decimal, add zeros, and finish it. But we're going to stick with the, elementary school. I like elementary school. It's fun, so we're going to stay there. Your elementary school teacher probably said, hey, when there's no more numbers to bring down, when this number is smaller than your divisor, you just say, oh, it has a remainder of 1, right? So what would be the answer? What would be sort of the sentence that we would write? We would write, all of this work here says that the 7,341 divided by 4 is equivalent to 1,835, right? This answer here, this quotient, with the remainder of 1. Now, sure, we learned about decimals and place values in middle school, but in high school, we learned that the remainder is just a parts of the whole. So in high school, the way we would handle remainder is you would say, okay, it's 1,834 with the remainder of 1/4. It's 1 part out of a whole of 4. So I hope this right here should not have been anything new. I mean, it's very comfortable. It's very nice. Hopefully it brought some wonderful nostalgic memories for you. My idea is that we can substitute these regular numbers for x squares, x cubes, x to the fourth, any polynomial equations that you can think of, and the idea is still 100% the same. So contrast this example with this example. Suppose I ask you to divide, say, 3x to the fourth minus 5x cubed minus 8x squares plus 4x is minus 6. I want to take that polynomial. That's a x to the fourth problem. That is a ginormous polynomial. And I'm going to divide it by x squared minus 3x plus 5. Right. It is my claim that conceptually there's nothing different about this problem compared to this problem. Although, realistically, yeah, there's a difference. This one looks harder. It looks, but it isn't. So we set up the same way our elementary school teacher would have. We set up the division bracket. We put our divisor, the thing that we're dividing by, on the outside. And we put our dividend, the thing that we're dividing into, on the inside. Right. Same setup. Hopefully it's very comfortable, very, straightforward, low stakes, low stress. And then what was the four-step process division algorithm? Divide, multiply, subtract, bring down. It's the same operations here. I do want to put...
Osorio, Emmanuel Osorio, please report to the front office.
I do want to put a little footnote here. Sometimes when it comes to polynomials, like students, you guys get so overwhelmed. You look at the big picture. Remember our first step here? The very, very, very first dividing step, we did 4 into 7. We didn't go 4 into 7341. So when you divide, you only look at the leading terms. Just like how we didn't look at the entire 7,400 whatever, you only looked at the 7. When I do our division step, you only look at the leading terms. Don't look at the big picture. It's going to be messy. It's going to scare you. You only look at the leading terms when you divide. So the first step would be 3x to the fourth divided by x squared. Now, I will admit I've been doing mathematics for a very, very, very long time. I can do that in my head. If you're not at that stage yet, if you can't do that in your head, I promise you, there is no shame. Take out some scratch work. So I'm a student that I can't do 3x to the fourth divided by x squared. So I'm going to write it down. 3x to the fourth divided by x squared. Oh, now I can see, hey, I got x's on top, x's on the bottom. So sometimes if you can't visualize in your mind, my suggestion to you is just to write it down. But I hope we can see that we can cancel out the x squares, giving us 3x squared. So that's what we're going to put in the numerator here. I guess I should color code this. So 3x to the fourth over x squared equals 3x squared. So I'll put that here. Then the next step is to multiply, just like with regular division algorithm. So you take your quotient here, and then you multiply it with the entire divisor. And again, I usually do this mentally because I've been doing mathematics for a very long time. If you're not at that stage yet, just take some insurance and write it out on scratch paper. So the next step is to take your quotient and multiply it by the entire divisor. Right? And then it's just straight up distribution. So that's 3x to the fourth minus 9x cubed plus, that's a 5, 15x squared. And just like with the regular numerical example, we're going to put that inside our division bracket. Next step is to subtract. So I'm going to take this whole result and subtract it. Do not, I put it in parentheses. A common mistake I see when students do this is they subtract the first term, but they don't subtract the other. So I'd say get some insurance and wrap it in parentheses. Now, again, there's no shame in this, but I've been doing this for 9 years, and there's one immutable fact that I've learned. You guys aren't that great with subtraction. I'm not saying you don't know how to subtract. I'm saying you make silly mistakes when it comes to subtraction. You guys know yourselves better than I do. So if you know you are the type of person that goes, you know what, Mr. Vo, I know that 3 minus 5 is negative 2, but I just keep writing a plus 2 there because I make those mistakes. This is my suggestion. Take it or leave it. You don't have to do this. Every single time you subtract, just change that to a plus symbol and flip all the other signs. For whatever reason, addition is a lot easier than subtraction for students. So I'm going to change that subtraction to a plus, and then change this to a minus, change this to a plus, change that to a minus. That's my suggestion. You don't have to do it. If you're okay with subtraction, go ahead and leave it as subtraction. But I'm going to take some insurance. So go ahead and subtract. These guys cancel. So -5 plus 9 is a +4. -8 plus a -15 is a -23. And notice how I'm saying that. I'm not saying -5x cubed plus 9x cubed because I lined them up. I don't have to worry about the variables. I just worry about the coefficients. And then, of course, the last step is to bring down. So this is not the final answer, but I want to make sure everyone's comfortable with the fact that, that's the same 4 steps as we did before. Conceptually, there is no difference between dividing integers and dividing polynomials. Because again, as we discussed at the beginning of the unit, polynomials are just abstract representations of integers when you substitute a particular number in. Any particular questions with these 4 steps here? So if you ever forget about dividing polynomials, just go back to 3rd grade, 4th grade, 5th grade. You divide, multiply, subtract, and bring down. Well, if there aren't any other questions, I think you guys get the idea, yes? I'm just going to fast forward through the rest of it because we do have like 2 or 3 more iterations, but it's going to be the same 4 steps. So I'm going to say my work out loud. I'm not going to use the scratch paper, but if you're ever wondering, hey, Mr. Vo, why is it there? Why is it that? I'm just doing division, I'm doing multiplication, I'm doing subtraction, and I'm bringing down. So let's go ahead and do that. So we divide. You only look at the first terms. So 4x cubed divided by x squared is a positive x. You multiply. Take the positive 4x, multiply. You take the 4x and you multiply with the whole divisor. So distribute the 4x, you get a 4x cubed minus 12x squares and a plus 20x. I'm going to subtract. I know myself, I'm a student that makes mistakes when it comes to subtraction. So I'm going to change it to a plus and then just flip all the signs. 4x cubes are gone. -23 with a +12 is a -11. A +4 with a -20 is a -16. Again, I don't have to worry about the variables if they're all lined up. Bring down. And then I have one more iteration to go. I divide again. When I divide, I only look at the first terms. So -11x squared divided by x squared is a -11 or a -11. Multiply. Take my answer of -11, multiply by the whole divisor. So that's just distribution. -11x squares, positive 33x, -55. Subtract. Again, if you don't like subtraction, change it to addition if you flip all of the signs here. And then that cancels. -16 with a -33 is a -49. And then a -6 with a positive 55 is a positive 49. Now, when it comes to regular numbers, it's very easy to know when you're done. The number I have is smaller than the divisor. How do I know if I'm done with polynomial division? There's 2 ways you can tell. Number 1, I've run out of stuff to bring down. When you're out of stuff, you're just out of stuff. You can't do it anymore. But mathematically, the formal way to know is take a look at the degree. This is a linear factor. Take a look at this degree. This is a quadratic factor. When your dividend is smaller in terms of degree than your divisor, you know you're done. But what do I submit? I mean, I would not take this piece of paper and show it to your professor. No, they're not going to say, what is this mess here? This is your scratch work. Just as before, we do want to write our answer nicely and cleanly. So your answers, your quotient, will always be up here. So if I ask you to divide these 2 polynomials, what I would submit as my answer is your quotient up here. So that's 3x squares plus 4x minus 11. But we did have a remainder. So in high school, the way we handle remainders is you always add the remainder over your divisor because it's part over whole. There. So that's long division. It's sort of anticlimactic. I mean, long division is, when you look at it, I mean, take a look at this entire work. It looks like we're doing high-level fancy math stuff, and I suppose to the uninitiated, you can take this to your younger sibling or young kids and go, hey, look, this is the stuff I'm doing, and they're going to be so impressed because it looks like it's, ooh, that's calculus and beyond. But really, it's in secret, it's just we're doing 5th grade math. Or, here's the cool thing, we are applying 5th grade ideas to a high-level idea. Right. Okie dokie? Instead of just like drilling a whole bunch of examples to you, I do just have a few cautionary tales. So for these next examples, we'll set them up, but we're not going to solve them. I just have a few heads up, red flags, warnings, whatever you want to call it. Call them tips, call them suggestions. Suggestion or tip. Here's my suggestion to you. You do not have to listen to me. Yeah, that's a very novel idea, students not listening to me. But I suggest that you do it because it might save you some headache down the line. If there are, quote, missing, and I'll put the word missing in quotes, missing terms, use 0 placeholders. Now, I call this a suggestion and a tip and not a rule, because if you don't follow this, you know, the world's not going to blow up. You're not going to get the wrong answer. It's just you got to do a little bit of extra thinking in your head. And again, take no offense to this. You guys have enough stuff to think about. You can't cram one more thing inside of it. So I'm trying to make things as easy as possible. What do I mean by missing? Well, a picture is worth 1,000 words, so an example must be worth a few hundred. Say I gave you something like this. Heck, I'll just make it up on the spot. 4x cubed minus 2x plus 1 over x squared plus 6. Suppose I ask you to divide that. We'll set up our division bracket. Again, we're only setting this up. We're not going to solve this. Now, we are dividing by x squared plus 6, so that's what goes on the outside. So I write an x squared. Now, you guys agree that the degree is a 2. So what I mean by, quote, missing is a complete polynomial will start at the degree and have every single exponent below it. So if I start with an x squared, I need to have an x, and I need to have a constant. Well, this guy here is missing his regular x. So I would write plus 0x plus 6. And then I put the dividend on the inside. So here's my dividend, 4x cubed. Now, since the degree is 3, since I've established I'm starting at 3, when I go downwards, I need to have an x squared, I need to have an x, and I need to have a constant. Well, this guy doesn't have an x squared, so I'll put a plus 0x squared, and then finish off the problem with the minus 2x plus 1. Then I'll go ahead and go through the process. This doesn't change your numbers. This doesn't change the idea. All it does is it just keeps things nicely lined up, which I think is going to be helpful for you. Now, you can get to a point, I personally do, you get to a point where you don't need to do this and you can just order things in your head. I would say until we are like a grand master at polynomial division, put in the placeholders. But it's not a rule. I'm not going to force you to do it. It's just a suggestion, right? You guys okay with that idea there? Okay. Now, I know what you guys are thinking, because for the past 9 years, students have been telling me this. In addition to, oh, this class sucks, I hate this, I don't want to do this, they also say, Mr. Vo, this is a lot of work. And then I tell them, it's just 4 lines, suck it up. But if you do think it's a lot of work, and granted, you know, it's not a 2-second problem, it's 30 seconds, 1 minute, there is a faster way to divide. However, it's only for certain cases, certain situations. We call this faster method synthetic division. Right. And it is personally my go-to method. I use synthetic division whenever possible. I say whenever possible because it's not always possible to use it. When can I use it? The idea is that you may only use synthetic division when you are dividing by a monic linear factor. And if you have no idea what monic linear means, that just means whenever you're dividing by a simple x minus a number or x plus a number. So if you're dividing by x minus 5, if you're dividing by x plus 2, that's what monic means. It's just a simple x. It can't be x squared. It can't be 5 x's. It has to be a regular x plus or minus a number. The reason why synthetic division is a lot faster is it only has 2 steps. The division algorithm has 4, and you have to use all of the equations. Synthetic division only has 2 steps. Multiply and add. Let's take a look at an example here. Suppose I ask you to divide 2x cubes minus 7x squares plus 5 divided by x minus 3. So just like with long division, there's a division bracket, but we do it sort of inverted. Instead of your regular division bracket, we're going to flip them upside down. We're going to make a giant L instead. Yep. This L, this is a very good method. It's my preferred method. This L has 3 rows. You have the top row, you have this inside row, and you have the bottom row. The top row will be the coefficients of your dividend. That's the thing you're dividing by. The inside middle row is where you put your products. And the bottom row will be your sums. Hopefully we remember product is multiplying, sum is add. Mr. Vo, what are we multiplying? What are we adding? What are we doing? Well, let's just fill the row first. So the very top row is the coefficients of your dividends. The coefficients are the numbers in front of the variables, right? They're just the numbers. Now, my little suggestion, hey, if there's anything missing, you got to put a 0. For long division, it's optional. For synthetic division, it is required. So I start with the 2, negative 7. I'm missing an x, so I have to put a 0 and then a 5. And again, if you're wondering, gee, Mr. Vo, where'd you get those numbers from? This came from my x cubed, this came from my x squared, this came from my x, and this was my constant. Synthetic division requires a single number on the outside. What number do I put into here? This will be the 0 of the divisor. 3. What is a 0? A 0 is a number that you get as an answer when you set it equal to 0. No duh. So here's my divisor. If I set the divisor equal to 0, x minus 3 equals 0, hopefully everyone can see that x equals 3, right? So that is the number that goes in here. Synthetic division only has 2 steps, and they're very, very easy steps. Add down, multiply on the outside. That's it. Add down, multiply on the outside. Add down, multiply on the outside. So let's do it. And the first step is always the same because this bottom left corner will always be empty. So step 1, add down. Well, that's just 2 plus 0 is 2. And then we're going to multiply. 2 times 3 is 6. And you put the 6 in the bottom middle row. That's it. That is one cycle of synthetic division. So you just rinse and repeat until you're done. Add down, negative 1. Multiply by the outside number, negative 3. Add down, negative 3. Multiply by the outside number, negative 9. Thank you. Add down, negative 4. You don't have to do this, but I always like to box that last number. That's just something I do. But again, just with long division, don't just show your professor this work. They're going to give you like, what the heck is this? You actually have to write down the answer. Well, here's the idea. Synthetic division will always reduce your exponents by 1. Always. So notice how our problem started with x cubed. That means these numbers on the bottom row is an x squared, x, constant, and remainder. So there we have our answer. 2x squares minus 1x's minus 3 plus my remainder of negative 4 over what we divided by. Synthetic division is a parlor trick, right? So a common mistake I get is students telling me, oh yeah, Mr. Vo, we divided out a 3. That is not true. We synthetically divided by 3, that's true, but we were really dividing by x minus 3. So that is what goes here. That is the answer I would submit. Now, if you're doing your practice and you're checking your answers, they may actually write the answer like this: 2x squared minus x minus 3 minus 4 over x minus 3. The reason being, if your remainder has a negative, sometimes they just sort of factor out that negative. I will accept either version. I will admit this one looks prettier, and that's what I would personally do. But if you gave me the top one in the test, I'll give you full points. There. So my suggestion to you, learn both methods. Yeah, I know, Mr. Vo, don't give me 2 methods. I want one that would always work. So here's my declarative statement. Long division always works. If you're just going to pick one method, long division will do everything. It'll take a long time, but it'll do everything. Synthetic division only works when you have monic linear terms. The reason why you should like synthetic division, besides the fact that it saves you a lot of time, is it can do some pretty cool things. What are some cool things it can do? Well, we have this little neat theorem called the remainder theorem. And the remainder theorem says this. If you have a polynomial, say f of x, so if f of x is a polynomial divided by a monic linear factor, say x minus a number, say x minus c, then the remainder of that division is equal to f of c. What that means is the function output are nothing more than remainders of monic linear division. How can that help us? I will say this. This theorem is super duper important if you go to college and take abstract algebra or if you take number theory. But quite truthfully, for us at this level pre-calculus, we're not doing abstract algebra. We're not doing number theory. Its usefulness is providing cheap entertainments on those lonely Saturday nights and you have nothing else to do, right? It's a pretty cool trick to it's sort of like a magic trick. Hey, get an unsuspecting person and go, I bet you, $5 I can evaluate this function in my mind in 10 seconds. What do I mean? Take a look at this example here. If f of x equals 3x to the 5th, wow, now we're doing x to the 5th power now, plus 5x to the 4 minus 4x cubed plus 7x plus 3. That is a huge polynomial. I'm going to ask you to find f of negative 2. Yeah, that was sort of an anticlimactic example. Off the top of your heads, if I gave you a function and you saw this, what does that tell you to do? Just plug it in, right? Easy peasy. Right, so f of negative 2 equals 3 times negative 2 to the 5th power plus 5 times negative 2 to the 4th power minus 4 times negative 2 cubed plus 7 times negative 2 plus 3. And let's say you didn't have a calculator. That would take you some time, maybe half a minute, maybe a full minute. Negative 2 to the 5th is negative 32 times 3. What's that now? Then I can do 5 times negative 2 to the 4. That's going to take some brain power. It's not hard. You guys can do it. Heck, even if I let you have a calculator, it's going to take some time to push those buttons. What the remainder theorem says is I can skip all of that, right? I don't have to do it the hard way because, according to the remainder theorem, if I do synthetic division with this number here, negative 2, with this function here, so what's that? That's 3, 5, negative 4. He's missing an x squared, 0, 7, 3. Synthetic division, this here, should take you 10 seconds. 3, negative 6, negative 1, 2, negative 2, 4, 4, negative 8, negative 1, 2, 5. 5 seconds, 10 seconds. I don't have to do any exponents. I don't have to do any combining like terms. All this work, what does it tell you? I can guarantee you, I will bet money that if I plugged in the 2 into that equation, I'm going to get a 5 out. So that's what the remainder theorem says, that the remainder of any synthetic division is the function output when you plug that 0 in, or when you plug that root in. So that's a pretty neat parlor trick. Like I said, for our level, this is as much as we're going to use with it. You don't really use this until you get to abstract algebra or any advanced algebra class. Where synthetic division really shines is when it comes to factoring. This right here is like real math magic. It's like we're doing the impossible. Suppose I ask you to factor and find all roots of f of x equals x cubed minus 7x plus 6. Forget it. It's a trinomial. Okay, we know how to factor trinomials, right? It's those two parentheses. But oh darn, that only works for quadratics. This is a cubic function. Oh, I know. Cubic functions. We factor those. We do factor by grouping. That's how we did cubic functions. Oh darn, factor by grouping only worked for 4 terms. I only have 3 terms. For all intents and purposes, is this a hard question? Yeah. I don't know how to do it. I wouldn't be able to factor this as it stands right now. But what if, okay, I threw you a bone. I feel sorry for you for once, right? And I'll, you always ask us in the question, hey, Mr. Vo, how do I do this on the day of the test? So I'll tell you this. You know what? I'll give you one answer. I'll tell you that x equals positive 1 is a 0. So I'll make it easy. I'll ask you to factor this guy and solve him, but I'll give you one of the answers. Okay, that's neat. That's nice. So what? Well, what division does is it breaks down problems. It makes the problem smaller. The only reason why this is a hard question is because it's an x cubed. And so far, we've only really been doing quadratics. Well, if I give you a 0, remember, synthetic division uses zeros. So the technique here is just to synthetically divide it out. Okay, you got a 1 here, you got a 1, 0, negative 7, and 6. And let's see what happens here. So we got a 1, 1, 1, 1, negative 6, 0, as expected. But remember, these numbers mean stuff. What do those numbers mean? X squared plus x minus 6. Hey, this is a lot nicer. This is a quadratic. We're used to quadratics, and it's a quadratic trinomial. What did the instructions say? Factor. We should feel comfortable factoring this. This is in our wheelhouse now. This is the stuff we've been doing for the past 3 or 4 years. So now I can factor this guy like normal, x plus 3, x minus 2, right? Now, a common mistake I get is students factor this, they box it, they submit it, and then they move on. I would mark you wrong here, because this is the factored form of this quadratic. This is the original problem, so I need to write the factored form of that guy. How do I do that? Well, we have this, we'll put this on pause. Pause. We have this theorem called the factor theorem. Well, the factor theorem states, if you know a zero, now, again, as I stated yesterday, the word zero, there's a lot of different names for it. You could also use the word root. You could also use the word x-intercept. You could also use the word solution. Right, they all have many words. So if x equals whatever number is a zero, then x minus that number is a factor. So if I want to actually answer the question, I want to find the factored form of the original problem. Yes, I do have these factors here, which is part of the answer, but I need another factor. I need another factor from this zero here. So according to the factor theorem, so we're resuming here. Resume. If x equals 1 is a 0, then I automatically know x minus that 1 is a factor. So we can factorize the original problem. Therefore, f of x equals the x minus 1 that they gave us with the 2 that we found out. X plus 3, x minus 2. What did we just do here? We factored something that was once impossible. We factored something that was once not factorable by our normal means, which is a pretty cool idea. Now I can go ahead and answer the second part, find the zeros, or find the x-intercepts. Well, that's sort of trivial. That's child's play the moment I have it in factored form. We have x equals 1 that they gave us. Here it gives us -3 and +2. So that would be the solution or the answer to the original problem. So dividing polynomials has one important power, one important task. It allows us to break polynomials down, which is good because the rule of thumb is if you are dealing with a polynomial that has an exponent bigger than 2, that's usually we don't have skills for that. So the moral of the story is try to reduce your problem down into quadratics. The last thing that you could do with this factor theorem is go reverse. Every single one of these problems, I gave you an equation, and we either factored it or solved it. Well, it is possible to go in the exact opposite direction. I'll give you the answers, and I'm going to ask you, hey, what was the original problem? For example, suppose I asked you to write a polynomial of least degree that has x equals -3, 0, 1, and 5 as zeros, and the coefficient of x cubed is -6. Right. So with the factor theorem, we could be the mathematical version of McDonald's. They give you an order, and you produce the equation. So someone comes up to the drive-thru and says, yes, I want a polynomial. It needs to have x-intercepts of -3, 0, 1, and 5. Oh, by the way, on the x cube, I want a -6 in front of it. How are we supposed to answer this question? It's just an application of the factor theorem. So what was the customer's order? He wants x equals -3 as a 0. Well, according to the factor theorem, his factor would be x minus a -3, which of course we know is x plus 3. His other order is I want x equals 0 to be his answer. Well, according to the factor theorem, that's just x minus 0. Well, if you minus a 0, nothing changes. It's just x. His other order was x equals 1, which translates to x minus 1. And then his last order was x equals 5, which translates into x minus 5. Right? So that was just an application of the factor theorem. Here's an idea. Factors, they're the building blocks of polynomial functions. Factors are like atoms. They're like DNA. They create other things. So to create a polynomial, if you have the building blocks, you just put them together. Now, if we're talking about chemistry, that's making bonds. If we're talking about biology, well, I don't know enough about biology to know how cells are held together. Maybe more bonds. But in mathematics, when you put stuff together, that is multiplication. So that's the big surprise. How do I answer this question? Just multiply them all together. So my answer would be f of x equals x plus 3, x minus 1, x minus 5. Since multiplication is commutative, it really doesn't matter the order in which you write them. I just like to write the monomial first. And then you just do repeated distribution. Right? Can I assume we all know how to FOIL?
Yeah.
All right, so I'm going to fast forward through this, but you guys know you just distribute. Do remember when you distribute, you can only do 2 at a time. So I would not, don't do this. Drew. That's bad. You can't do that. You have to do 2 at a time. So let's do these 2 first, just because I feel like it. So I'm not going to do anything with the first 2. And then I'm going to multiply these 2 guys here, which, again, I'm going to fast forward through it. X squared minus 6x plus 5. And then let's go ahead and distribute these 2 here. This one I can't do in my head, so I have to actually write it out. That's x cubed minus 6x squares plus 5x's plus 3x squares minus 18x's plus 15. And then you just go ahead and combine like terms. X cubed, so we have this guy here and this guy here, so that's a minus 3x. We have this guy here and this guy here, which is negative 13x's, and then a lonely 15.
It's negative 3x squared.
Negative, oh, thank you, negative 3x squared. Yep. And then last step is distribute the x. X to the 4 minus 3x cubed minus 13x squared plus 15x's. Yep. But, oh wait, the customer had one extra order. I want a negative 6 on the x cubed. Oh crap, we have a negative 3. So that is the idea. In terms of polynomials, it is completely legal to multiply by a non-zero number and retain the x-intercepts. So if all I want to do is change the appearance of an equation without changing the x-intercepts, you can just multiply by whatever number you want. Well, I have negative 3, I want negative 6, just multiply the whole thing by a 2. So then my actual answer would be 2x to the 4th, or f of x equals 2x to the 4 minus 6x cubed minus 26x squared plus 30x's, right? Just multiply everything by 2. It's a very, very big order. So polynomial division. We are doing 5th grade math here in the context of complicated algebra. But with the remainder theorem, we can do cool party tricks like evaluating functions without plugging stuff in. But more importantly, we can break down really big polynomials, which are hard, into smaller, easy to swallow pieces. With the factor theorem, we can design polynomials. If you are given a set amount of x-intercepts, you should be able to create whatever polynomial function you want. So that is 3.3.